Hello guys, and welcome to another episode of Radical Dream Play, where I want to take you on the journey of the development of the F1 pitstop planner that I developed in Python. I'm still busy with it. I just want to go through the history. Hope you enjoy. This is the first commit that I've made of the app. You can see first I just tried to create a track. This is not any specific track yet, and I plot it so I can run this in Python. And yeah, it's not the best looking track. Got a very dangerous intersection here to test the driver's reflexes. Hopefully there's a bridge there, and then a very sharp corner here, almost a hairpin. Yeah, but that is just how I started. I knew I needed a track, so I tried to see in Python how I can create a track. And then I tried to add track width, but here is a width, very narrow track. So how you would add a width is to get the gradient of your x and y points of the track, and then you want to find the line perpendicular to it, normal to it, nx and ny. So if you have the gradient dx and dy of a line, then there's two options. The one is you can make nx negative dy. You swap the x and the y basically. So the two options is you make nx equals to minus dy. The alternative is ny equals to minus dx. Then you have nx equals to dy. And that is two normal lines to the line. Problem here why the width is not right though is I summed here and used the whole track length. I should have only used a segment length here. So this should really be segment length to normalize with. Now the track should be fine if I run it again. Yeah, now we have it's 10 to the left and 10 meters to the right. So the total width is about 20 of this track. But yeah, that's how you would do a track width. You would use this nice Python gradient function and then just do this to get the normal vectors to it. So by dividing it by the segment lengths, which is the Pythagoras of x and y, you get unit vectors, which you can then multiply by the width. That's only the first one, is trying to get the track. Then I shifted the track. I like the start line to be at 0, 0 of the figure. So that's what I aim to do there. Yeah, I just added some offsets to x and y. So yeah, here things got sorted into folders. And yes, I put the tracks into npz file. So you get the npy, that's where you store a singular array. When you want to store multiples, you use npz. And it's also compressed, but it is just multiple arrays that you can store into npz. I store a lot of data. I store the tracks in there. I store the grid data currently in there in the latest commits. Here I didn't have grid data yet. I didn't have drivers, cars yet. But this one does. If I run this, it doesn't receive a response from the server. Yeah, this API, I don't know if they took it off. So we can load the npz files. I must check that for new track that I want to get. I don't know if I must find another API, another URL that I can use. Okay, so here's circuit. You can see I've shifted it so the track has the 0, 0 more or less at the origin. I like them to work with smaller numbers. Before that, this track was like those very huge numbers. This is now the Yas Marina circuit, as it is still today with this hairpin. I think the old track had a turned left here and then had a sharper hairpin perhaps, but there was something different here and here as well. But yeah, okay. Oh, the spline. The issue with the spline was that there's a lot of points. I'll show it in a later one. If you have points that's too close to each other, then you can't use spline on that data. You can't give it the same point over and over. A lot of these x and y points, they lie exactly on the same point almost. So spline was complaining about that. Yeah, you see in this commit, yeah, I'm working with segment lengths, not the track length, to get these nx normal vectors normalized. So that was fixed in this commit only. Then I cleaned up. Yeah, then I made the main simpler and draw the call functions that I put in a track.py script or the create track pi. I call the functions from main to make main a lot simpler. Okay, so here the spline was resolved and run this one. Okay, yeah, here you can see a nice track width applied to the Yas Marina Abu Dhabi track. Yeah, this looks like a race track now. I've removed the track width in my latest code and I think I must reintroduce it. It does add a nice look to it. Currently I'm just using a single line. I think I'll reintroduce the track width. So the spline error that we saw previously. So everywhere I make sure the distance between adjacent points in my track points, and then make sure they are bigger than some minimal value. If they are too small, if they're closer than this to each other, then I don't use them. So I only insert these values that are far enough, I consider far enough apart, and then I fit the spline through the data. The order is, if it's 0, it will go through all the data points. If it is 1, it would be quadratic. 3 would would be cubic, and then I make sure that it's periodic, meaning the beginning and the end points are the same point because it's a track. It repeats itself then. And then I create 2000 linearly spaced points and I evaluate the spline at those linear points. And I get a nice smooth track that I then save into an NPZ file. So from now on, I just use the NPZ file. Here I still call it center line, and then I remove the center line because it's just extra naming, and for this app, you don't really need a track with a width, but I see visually it looks nice. So let's maybe introduce it for aesthetics. There I removed the center line wording. This is an interesting one. I added the heat map. So why do you want the heat map? Well, what is the heat map based on? So the heat map was created by using the heading angle. So by using the heading angle, I can more or less say car can go fast or not at certain places. So here's the track. Heat map, Savitsky-Goulet filter. It's like a moving average filter. Look, moving averages, you must always specify the window as an uneven number. So it will take 11 points. The reason choosing uneven is this filter, it doesn't care how far the data points are apart really. So if you specify uneven or an odd number, it would take the middle point as the center, which is a nice thing to do. So it's always good to specify uneven numbers for moving average filters, and this one will apply a third order polynomial fit to that set of data and then move on to the next 11 points of data. And then here you calculate the heading for the heat map. So you get the gradients on X and Y, and using arctan of those two vectors to get the heading. Then I unwrap it because it's a racetrack. It's going to complete a full circle. You don't want the heading to be wrapped from -180 to +180. So we unwrap it to make sure we get all the heading angles, and then we find the gradient of that again. The sharper turn, the higher the gradient, then you want the color to be darker or more red, just to show on the heat map. Here you can't go fast because the heading of track changes too quickly. We don't care if it's a right hand turn or a left hand turn, so we use the absolute values. We just want the sharpness of the turn. Okay, so you want to clip this always when you work with heat maps. You'll see a lot of the times heat map have a lot of data at the endpoints where you just go deeper into black, for instance. So there's no point. You lose a lot of data if you have too much edge data where the value is, let's say, from 95 to 100. I mean, at 95, you already can consider it 100 and rather get more different values over the whole track. So you play with where you slip it to see that your color bar is nicely spread out, at least have some info in it. So then we plot that, make sure it's 0 to 1, and then we use color map turbo. I think it was Jet old one, but this one is apparently new and improved. Then you plot it, and then you show the plot. Color bar, let's run this one. You can see a 1 is red area, you can't go fast there, and then blue, nice and fast zone, the DRS zone, and you see here you want light green. If you had too much data here on your edges, this would have all been the same color in the center, for instance. So you spread it out nicely, so you decide where you clip. But now we can apply this data to the speed or the average lap time to get the cars to go faster and slower around the track. Currently, I'm not using this heat map. I'm thinking more of linearizing the tool. The whole idea of this tool is to have it, I call it almost like a pit stop calculator. A calculator, I mean, it's quick and easy to update it with the latest state of the race. That's how I want it. And then if you assume constants, look, you're not going to be able to predict someone crashing, tire bursting, the weather changing. Even full non-linear models even have that incorrect. So I rather want a constant linear model that you can quickly update, not too complex, and then you can get good data should you put now or within the next 5 laps. But we'll see how complex it becomes. That's just some background info of where I think we're heading towards currently. Then we added cars. Definitely need to check out that. So here's some scatter. I use scatter. So this was probably still very CPU intensive. You don't want to look at this code really. You want to recombine it now and use a single scatter for all, and then we offset. We still use that offset. But let's run this one and see. Here's the race. So yes, now we have a race going on. And some colors, different color cars for the different teams. You see, this is the thing. If you drag this around, you'll see it's very glitchy, and that is what multiple scatter does. So it's nice, but it's not that nice. You should not. It's a bit intense, this one. Even the latest one you can drag, it's very smooth, and it's got a lot more functionality currently. Okay, then we start looking at GUIs. Here's TKinter. Then we added the GUI to the code. Let's see how the first GUI look. When you see root main loop, if you don't have it, it will open the GUI and close it immediately. So that basically root.main loop it tells it, hold on, let's check if there's any buttons being pressed, any mouse click, and it will call the appropriate functions then. Let's run this. See the first GUI, but now here's legends added for the different drivers. Okay, so then I added grid data. First it was called drivers. I think it's now called grid.npz. Of course, it's not just the driver details like names and team names and colors. It now also contains their position, that time, delts in. But this function, yeah, that is one still exists. Also the move up, I think they changed a bit. Yeah, so I think this one we can skip for now. Okay, then you don't need to calculate the length of the track during each iteration. So I did it globally, and then you can just use that whenever you update change tracks, you can calculate track length again. Or one can also store it part of the npz file, really. Hopefully the track doesn't change with time, right? It's good to have a function to calculate it. Yeah, otherwise if you make your npz too complex later, you want to create, you don't know how to create that npz again. I would rather keep things simple and subsystem. So you have your tracks, it's just track data. Rather have a function that works, that can always calculate the track length for you. Yeah, get track length. Okay, that calculates and returns it. Yeah, you can see there's a lot of commits, small baby steps. Here is the single scatter and then enabling blit. You see, blit I had to later disable again. Blit, if it's active, if it's true, then it only updates on plots, for instance, things that change. It wouldn't run everything again. But let's say on that track where I use legends to show the driver positions, you want the legends to change. Obviously, you want the first guy to be on top in the legends. So that only happened later in the commits. And then you want blit off. You want blit false, so you're able to update the legends. Otherwise, it will not update. It only updates the necessary minimal changes. So it helped to get it faster. But I think here the biggest improvement from this commit, I didn't know it at this time, probably it was the single scatter. Yes, so here we got the stuff to work a lot smoother. So scatter is a very heavy function. Scatter is like your Excel plot of just data points. It doesn't connect the points with lines. Bunch of dots on a plot. So that these are just dots, which is defined as large circles with different colors. So the single scatter can look through the code. You won't see multiple scatters anymore. Yeah, here I created 20 points for the 20 cars. That's one scatter. And you just set the offsets. You don't create a scatter each time in the update function. You just change their position. Yeah, that's basically. So the animation here is in the main script. And then here I moved it to its own one. I've moved it back to the main, to be honest. So a lot of the things you try, and you try to optimize it, try to get it working at the same time. So it's a bit of going back and forth. So I moved it here to its own script. Started using Custom TKinter for a newer, better look. CTKinter. Oh, there's even just pronouncing TKinter. There's a lot of debate how you pronounce it. Is it TKinter? Now you get CTKinter, Custom TKinter. But anyway, it's just a better, more appealing look that you can get your GUI now. You see? Now it's more a bit of a modern look. Here I still used green as the color. You can select your tires now. All of this was built into the GUI. And the different team names and the driver names. And then I had a separate tab for the circuit still. And white here. Why white? I'm a dark theme. I like dark themes. I think it's better on your eyes. It reads easier, and you can switch between these tabs. So this, I then later combined these tabs, then did some house cleaning, some dead code, added a scrolling frame now. So you can scroll between the drivers up and down, and some proper race names, teams names was added as default. So here it started to look like a racing app. The circuit track is now at least a dark theme as well. You can simulate here. We've got a simulate and pause button, and that toggles, then it stops immediately, pauses there, and the name changes to simulate, and then simulate changes to pause again. You can pause in this tab as well. It should pause in both tabs then. See, unfortunately here, what started to bother me later is that you have to switch tabs. Here, I want to have this info available as well as the circuit. You want to see both screens simultaneously. So that's something we'll get to very soon. Now let's just put some variation on the track and look at that. Well, that's not much variation I've entered here. But yeah, there's definitely still bugs in here, but getting the general thing going. Here then I removed the NPZ driver drivers. I stored the drivers in its own NPZ file. I later moved everything to one NPZ file. There's no point in storing data in different files necessarily. You already store the grid order in grid, so might as well store the names there directly. So here I started playing more with the delts calculations. So the delt column gets updated, and then I renamed teams to teams underscore. I don't know if you guys do something. So what I do is whenever there's an underscore at the back of a parameter name or a variable name, it indicates to me that it's an array. Normally, like you would write a vector with a stripe on top or below it. I just do this to show in code that this is a vector and not just a scalar. Please share with me anything like this that you do in parameter names to indicate some sort of type of it without typing. Or yeah, even if you type the whole type, yeah, I would be interested to know about that. Yeah, please share in the comments your tricks that you do. I've always done an underscore, then I know it's not a scalar. So yeah, here all the information is now available nicely on one screen. I've moved the driver information to the left and kept the track here, or moved it to the right hand side, so you don't need to use the two tabs anymore. You can just use the driver tab and simulate the cars here. You can see all the info here, the delts between the cars, average lap time, all of that, and the race and the track on one screen. So you might notice the screen size, it's not nicely using the full screen. I've designed the app on a different screen. Here is the code where I figured out the screen width and height, where I worked on that. And then strangely enough, yeah, so I had to maximize the screen each time I run the program. So I found this function that you can call that zooms it in, maximizes the app, but here you have to run it after a certain time, after 100 milliseconds or something. So you can't just run the zoom immediately. It just does not work. You have to use some after time, which I found is very interesting. So here you can see I added a reset all button that basically just resets the delts column, laps column, average lap time column, updates the time that is displayed as well. Let's say here was values in, or let's simulate it a bit. Okay, all the cars have the same, so there's one dot. Let's give them some offset. Yeah, it's not perfect yet. I mean, here's Piastri and a Mercedes, and the colors red used to stay in front here. Still bugs. We'll get to them. They're resolved now. The thing was here, I was focusing on resetting everything. You must make the tool work for you. That's the easiest to debug things, is have your buttons so you don't have to enter data the whole time. Here I worked on getting the tool to help me to debug the tool. You see it pop immediately to full screen due to that after function where you call the zoomed in. Okay, so here you can see now finally the issue about the colors, updating the legends, and you can see here cars overtake. So the overtaking now appears to work better. A couple of things that I had to sort out. So one thing was the delts. I used that to see when cars overtake each other. So delt I now treat more as just a display parameter. It's not really used in the code. You must decide what is your dependent variables and what is the variables that you simulate rather. So I don't use delts at all. It's only for display purposes. So that's calculated. And I use the time, the race time, as well as the average lap time to determine which car traveled further than another. Obviously from the start I have different grid positions, so I keep that also and subtract that because that's not counting as overtaking a car. That's just to get on par with a car during a race. You can see here now the color is white. That was fixed, but at least the legends move, and to update the legends you had to put it as false again. Okay, so this is a feature my wife actually asked me to implement, and that is to select a driver you want to indicate on the track. Here I've just added the selector. You can select which driver, and later there will be a big ring around that driver, but it's all in steps, baby steps that we take in software development. So we added the selector here, and now you can see also track and the legends are dark themed. I like all my information on one screen. Okay, so the next thing I added then after being able to select the driver is a plus lap and a minus lap, where you can jump a lap forward and it will use the driver that you selected. It will use that one's average lap time. So if you say plus lap, we'll look at Piastri's lap time, for instance. Where is Piastri here? Let's change his to 10, which is easier to see there. So we go plus lap, it added 10 seconds, minus lap, it subtracted 10 seconds. And then later on it will update the position of track as well. Currently, I think if we have a big difference in times, I'm not sure if it will show it now already. Cars jumping now. You can see things happening here in the grid, but no changes here. Set all, make Alonso slow guy, and we want to focus on Alonso. Alonso is purple. It's not the nicest color. I'm still thinking of changing this purple to some other color perhaps. Yeah, you see the plus lap, minus lap here is not quite sorted, implemented fully as I want it. Not at this moment, because you'll see, because they're traveling at different speeds, if you're focusing on Alonso and you add a lap to him to be at that same spot again, obviously the other cars must be at a different spot on the track. So you'll see that later. Okay, so here I named it minus lap and plus lap and swap them around rather than having plus and minus spelled out, just to make it easier for the user. I don't want to read a lot, so you can, let's pause it. Yeah, here's some drivers with different speed now. So here the selector, it should work here. If we choose Hamilton, and the other cars behind it, Hamilton is green one, and you now see the other cars are they different positions when Hamilton is at that same spot again, different lap. So you can go 20 laps forward. You see, this is where the thing comes in now, planning with this tool. You see, go forward and back, and you see how the car is arranged. And now you can see the reason of this app is you can go forward and backward to see where all the cars are on the track to do your pit stop planning. Here you can see I've added a time adjust slider. So it's just a long bar that you can slide back and forth to adjust the time of the simulation. I added a couple of returns for the functions. Now I just thought maybe it's good practice to have them there. I didn't have it. So here the slider bar was not very wide yet, but yeah, it was functional already. So you can go back and forth with a sliding bar, like a YouTube video that you are watching, or a Netflix. So you can see the markers for the pit entry and pit exit and the start finish line. I just put them more or less where I believe they are. I think pits are here, and then I think you go underneath here somewhere onto the track around there. Yeah, I must still add the track width, which I discussed earlier. I think I'll still see. I don't want to take away information or make the cars, see how the cars display on that if it's wider. But yeah, so see one feature at a time. So here you can see I added the function to swap drivers on the grid. So now on the left hand side in that column, you can change the numbering. So if you go to driver 5, for instance, and you change his number to 1, him and driver 1 would swap positions, which again my wife told me is not a very nice thing, but there you see we can put Hulkenberg, let's make him at pole position, and then they just swap places. Or we can put a race. No, let's make it rather Piastri. I don't want to upset you guys. I don't mind who is leading that much, but I like McLaren, I like Norris, I like Piastri, I like that. They're all very talented. So then here you can see the time bar is now nice and long, makes it easier to go back and forth. Oh yeah, a feature I was busy telling you. So this grid position is not really realistic. Why would one from the back just swap positions with one in the front? So I changed the logic. I'll show that later, where if I enter here a 1, everyone will move down. Piastri will not come to the 12 place like now, because that's not really accurate. And then you also need to, when you swap these drivers, you must also take care of the average lap times and the lap numbers, all of that, to keep that driver there. Otherwise the software might just quickly switch him back. So it's all things that you need to debug and handle very carefully. I just want to see here if you select the driver. No, it doesn't indicate it here. So you can see now we can select Russell. He's leading. This green car here is at the pit entry. Now we want to see, okay, we go forward with some time. Oh yeah, that's why later I've added, yeah, there you can see now it's at the pit entry. Now I can forward to see this is not there yet. I've added later some plus and minus time. You can jump with time, or if you expect the whole pit to take 22 seconds or something, or whatever amount of time, you can jump ahead with that time and see how many cars is here around the pit exit. And you can see, is there a problem? Is there a risk of, if the pit stop is longer or shorter, what will be the ideal? You can plan your pit stop and tell the guys, hey, you can take up to so many seconds. If you're going longer, we're gonna fall behind X, Y, and Z, or whoever. So here in this update, you'll see the grid swapping is now much better, as I explained. Let's say Hulkenberg moved to position 5. You'll see Alonso, he will go to 6. So here in this update, a few things changed. The grid swapping, you can see now I can put Sainz in 3rd place, and Leclerc will just swap one down. You see, so it's more realistic what would happen. You don't have drivers swapping from the back to the front. Magnussen put him first, very strange place for him, sorry. But yeah, and you can see also the cars are circled here, and to show you where which driver is. So a gold ring, that is obviously pole position. The silver ring there is 2nd place, and then bronze. So this is 1st, 2nd, and 3rd. And you can see there's a blue ring around the 2nd one, which the blue ring indicates the car that we're investigating. It's not quite sorted out here yet. Let's choose one of the Ferrari Norris, for instance, see if it goes to a red one. No, so it's not quite sorted, but Leclerc is 5th. So that's the 4th position. Yeah, you see here still a couple of issues with the colors, but at least now you can see which car is 1st, 2nd, and 3rd, or supposedly, and we can jump ahead, forward, and back with time. But since this is not working perfectly, let's go to a later commit to show it properly. So what I've done to the reset buttons also, they toggle. So every second time you press them, I know in UX, UI design, they say each button should have one function. So this is debatable if it has 2 functions now, but every second time it will take it to a constant value. Maybe I'll add some text boxes here where you can enter the constant value you want. The second time you press it, it's a random value. I'll just make it easier for setup. I like the constant 0.1 second offset between the cars, and the laps, reset all of the laps, and some random lap times. I like that. That works nicely now, spreading the cars out from the start. Okay, so this is the final software as I have it today. I'm going to be honest, it's not 100% bug free, but it's working very well what I wanted to achieve. So let me demonstrate. So I extended the time access to use the full screen. So I adjusted also the layout a bit to fit the screen that I'm using currently. Maybe let me just start running it. More random values here. Yes, let's start it. And you see Verstappen currently selected. And then, yeah, I've also added minus and plus 0.1 seconds. So not only can you jump with time, if you know something's going to take a certain amount of time, you can now also just for finer tuning, I think 0.1, maybe one can have more options here. So instead of specifying here a time, you can just quickly do fine tuning the minus 0.1 and plus. Since that is the resolution I'm running the simulation with, it makes sense. It's no point in going finer than that really. Yes, and then plus and minus laps, that is linked to the driver that you select here. It will take the average lap of that driver, average lap time, and jump one lap forward or backwards to keep that driver at the same position. But let's demonstrate. So you'll see, okay, there's quite nice randomization in this one. Now, what I've done, there's a few updates. Apart from getting the layout nice, you'll see these circles of the drivers now. It's plotted in reverse. So what I mean by that is the first one you plot is normally the first legend, right? But I want that one to be on the top layer. So normally when you plot multiple scatter points, the order is the first one you plot is at the bottom layer. Unfortunate. Don't know why that is the sequence. So the circles was the other way around. You will see someone in front being kind of below the dot of someone that is behind it. So what I've done is I plotted them in reverse order. The legends and the colors are updated with a patch handle. So then I only run that whenever you manually swap drivers here with the grid. If you do the swap here, it will run this patch handle update. Also, if the drivers overtake each other. So it's not something I run permanently to get the computational load reduced a bit. But then you keep this order as the order from which is first when you update the patch handle. So that you do as even the order I would have plotted the stuff. But I just plot the stuff in reverse first to get the layering right. It was an interesting thing to resolve. Okay, so I moved the reset buttons and I removed the extra text that says reset delts, reset laps. I mean, I've aligned them nicely with their columns now, reset average lap times, just to fit everything nicely. Now one can demonstrate the time bar, for instance. So if I press it now, it's going to jump to different points in the race. Here's the starting point. Here you'll see the leader is at the start finish. Let's say you want to investigate around lap 20, for instance, but let's say you have a specific driver. So let's take a real scenario now and see how this tool can help. This is the idea I've been dreaming about. So let's see how it would realistically work. So let's say someone like Piastri is here 6. So now we're focused on Piastri. We've got the blue ring around him. So we know we're not looking here at Norris. We're looking at the right car. And then, okay, so luckily he's close to the pit entry, but we need to take him a bit back. So we rewind the time a bit, because this is typically when when he would enter the pit. And now we want to see, okay, look, there's a gray car. There's someone close to the pit exit. Okay, but this is the same time, so that's not an issue. We want to know, I don't have an exact time idea. I know the pit stop itself is like 2 seconds or what, but I think the total time it takes from you to enter to exit is probably around 20 seconds. I'm guessing here, guys. Who cares? I'll just take 20 seconds. So let's say after 20 seconds, we want to know how is this pit exit area. Is it a clean area where Piastri will join the race again? So now we can go plus 20. It's ideal. So lap, what we're saying is for Piastri, okay, I could just go back 20 seconds. For him to pit in lap 21 is an excellent idea. What if he pitted in lap 20? How would that look? So we go 1 lap back for him. Now he's again still at the pit entry, and now we say, okay, 20 seconds later. Yeah, still good. And that is what I wanted to achieve with this tool. Very simple, because I think a lot of decisions can be improved with simple tools like this, which doesn't contain all the complexities of this highly non-linear environment. It is really a tool to show you the next 4 or 5 laps. The idea is to link this with real feed data, so you don't even have to update the state here manually. So that's maybe a good next step to look into. Get typical real, I'll probably use historical data when I design it or build it into the app. But yes, then this thing will run and you can at any time go forward and backwards in time. You'll see there's definitely times when the guy should not pit. We can put him back at the pit entry and then go a couple of laps forward. Check this. Yeah, you see this yellow car could have been a problem here. It's very close. So we know we must take 20 seconds or less if we wanted him to pit in lap 26. So lap 26, guys, don't take more than 20 seconds for your pit. If you take more than 20 seconds, you're going to have a problem when he exits or enters the track again, exit the pit. So that's the whole idea of the tool. You have your pit lane, entry, exit, finish line. You know where your leader is, gold ring around it, silver ring for second person, bronze for Sainz here in third place. I'm not sure if I missed something, but yes, you can at any time now play it further along from this point on, and you can just see how things play out. You can see he's overtaking, he's on top. Okay, he's overtaking someone that was behind him all along. To have so that's actually a nice thing to have your leaders or the person that is in front on a higher layer. Yeah, it's things like that that makes, here you can see it again, that makes it interesting. Let's see this white car. Well, he's gold, so he's in front. He's definitely going to stay above blue if he goes over him. Well, unless there's bugs, which, look, there's always bugs. Let's quickly see if I can break it like that. If I go, just keep on going. I would look for a swap here. So you see, it seems to, you see bugs are hidden. They're really sometimes hidden very deep. So, but I know here might be something still. You can use this app for a long time and not find, lots of software is like that. You can use it for a very long time without finding any bugs. But trust me, normally there are bugs and you need to thoroughly test it. So yeah, then we can reset. We can play with this until we break it. I'm sure we will manage. Okay, we've got average, different, nice offsets between the cars. I want to reset the time as well, so let's redo that. Yes. Okay, it starts nicely. Oh, the two Ferraris in front. Maybe one should be able to zoom in. I don't know. Do we want to? Yeah, lots of swapping of places here in the front, but at least you see the top layer color. I like that. That is the one in front. So all these dots would have been the other way around before that fix. So please, guys, let me know in the comments, what do you think I should add next? I think getting live data, getting historical data, maybe not live data yet. We can maybe test it one day, live data. And I can stream how that works. But what feature What do you think would add more value to such a tool that the guys can use? Yeah, I just like to develop. I'm going forward with game development. I would like to share that in the same way. I've built a few games now. Look, I'm a sole developer. I can't compete with AAA games, but I'm doing it for the fun of it. I think, and the more comments we can get, more inputs, the more fun we can have. If it is not too big things that you request, I'll try to implement it quicker and try it out. Even if it's funny stuff that you want to try, I'm all game for that, guys. Thanks for watching another episode of Radical Dream Play. I'll see you in the next one. Cheers.